Hello, friends, students of geometry. Welcome and happy Pi Day. Today is March 14th. I don't know when you're going to be viewing this, but today's March 14th, so happy Pi Day. You may not know exactly what pi is or how it's used. Well, you may have seen it in some things like, finding the circumference of a circle, and that's appropriate because we're talking about perimeter today. It's one of the topics. We've got three main topics: perimeter, area, and the Pythagorean theorem. So let's jump in. This should be pretty quick. Ideas that you're probably already familiar with. So first of all, perimeter, okay? So perimeter is the sum of the lengths of the sides of a figure, right? So when you take the full length around the outside of an object, that's called the perimeter. Peri kind of means around, and meter just means measurement. So it's the measurement around the object. And what we like to do in science and in math is we come up with formulas. Even in like economics, ultimately the goal is not just to be flying by the seat of our pants and having to figure things out new every time, but if we can come up with a formula, then that's very helpful to us because then we know when we have this type of thing, we can apply the formula. So for example, if you have a rectangle like this, then it has length and width. And the formula for the perimeter of a triangle, P stands for perimeter, is just 2 times the length plus 2 times the width. Nice simple formula, but it's all based on this idea of what. And then maybe you can come up with some other ideas, right? Like another formula for perimeter, the perimeter of a circle, since it is Pi Day, right? The perimeter of a circle is the circumference, and that is 2 pi r. Actually, that's how pi, and so 2 times r, by the way, 2 times r is the diameter, and so pi is actually defined as the ratio of the circumference to the diameter. You don't need to know that's not like central, but it's an extra because it's Pi Day. We're just feeling so festive. Area. Area is the size of the surface that's enclosed within a figure. So, for example, I'll start with the rectangle. The rectangle, length and width again. Here, the area is multiplied by length times width. When we say the size of the surface, notice now we're not measuring just length. We're measuring like a piece. It's a two-dimensional piece. So perimeter is a one-dimensional thing. It's the full length. This is a two-dimensional thing. The units for it then are squared. So if this was inches, you'd have inches squared. And then the formula for the area of a triangle is 1/2 base times height. The height is perpendicular to the base and goes up to the opposite vertex, the opposite corner, we could say. It's actually called an altitude, and that'll come into play later, but that's the formula for the area of a triangle. Okay, now another thing, the Pythagorean theorem. Okay, so this only works for right triangles. But when we look at a right triangle, it's got three sides. The side opposite the right angle, that's the longest side, always. The side opposite the right angle is always the longest side. When we're writing out the Pythagorean theorem, it's just kind of convention to call it C, but it also has a name. This long side opposite the right angle is also called the hypotenuse, and the two other sides are called the legs. The way the Pythagorean theorem works, this formula, is that the relationship among these sides is that a squared plus b squared equals c squared. The sum of the squares of the two shorter sides is always equal to the sum of the square of that longest side. And so here's an example of solving this, right? Here's a triangle, and we've got two sides, 6 and 8. These are the we call the legs. A squared plus b squared equals c squared. That's not an equals. Let's try it again. A squared plus b squared equals c squared. There we go. So a is 6, 8 is b, and then c is the thing that we're looking for. And so 6 squared plus 8 squared equals c squared. We're trying to solve for c, and so we're going to simplify and try to isolate c. 6 squared is, go over here, 36, and then 8 squared is 64, plus, not plus, keep doing that, equals c squared. So this is 100 equals c squared. You have to take the square root of 100, and so you get 10. 10 equals C. Normally, when you take the square root, you'd say plus or minus, right? But having a negative length of the side of a triangle doesn't make any sense. So the answer is just 10. That's how you do that. Here's an example where we're looking for one of the legs in this case. So here we've got the hypotenuse. We have one of the legs, and we're looking for the other leg. So when we kind of fill this in, this is B, and this would be C. Okay, and so this is A squared plus B squared equals C squared. And so we fill in A squared plus 24 squared equals 26 squared. Trying to get A squared by itself. So A squared equals, so I subtract 24 squared from both sides, and I get 26 squared minus 24 squared. That's just a little bit of algebra there. And now I need to calculate 26 squared and 24 squared. Okay, so when we do this calculation, we end up with A squared equals 676 minus 576. And this is A squared equals 100. So again, A equals 10. Okay. I'll let you in on something now. There are actually, these all worked out to be all whole numbers. When you're doing this, you're not always going to get whole numbers, but there are some what we call common Pythagorean triples. That is sets of whole numbers that can be the sides of right triangles. One of them, very common, and even like advanced levels of physics, right? I teach AP Physics, calculus-based AP Physics, and we see these types of triangles showing up all over the place. It's very common. People like to use them because you get whole numbers. Um, Theoretically, you can do a lot of them without a calculator because you just know these Pythagorean triples. Not essential to the lesson, but here's a little extra. So one of them is a 3, 4, 5 right triangle. The sides can be multiples of this. So this one is 3 times 2, 4 times 2, and 5 times 2. So it's a 3, 4, 5 right triangle. Another one is a 5, 12, 13 right triangle. And so 13 times 2, 12 times 2. So I knew that the answer was going to come out to be 5 times 2. These are Pythagorean triples. It's good to be aware of them. And then good also, you can start storing away some of these common Pythagorean triples into your mind. And that's it, right? So just this idea of formulae or formulas, perimeter, area, and Pythagorean theorem. Thanks for watching. Don't forget to like and subscribe, and happy Pi Day.